Okay, so just like inverse trig we had for derivatives, right? You had a list of inverse trig that for derivatives, right? We have it also for antiderivatives, for integration, integrals. Okay? The nice thing about integration is we only deal with three. With derivatives, you had arc sine, arc cosine, arc secant, arc tangent, arc cotangent, arc cosecant. You had all six of them. With antiderivatives, we only focus on three. Arc sine, arc tangent, arc secant. Those are the three that we focus on. So they're not hard, they're just a little tricky because you got to recognize when you see them. You got to recognize when you see them and when to use them, kind of like you did with derivatives, right? They don't happen a lot. There's not a lot of times where you see these, but just that relationship. If you see on the bottom, if you see a square root on the bottom and you see an x squared, probably it's going to be one of these guys, okay? So here's the three that we're going to tackle. If we see these relationships, here. So du, remember, move the du to the side and just put 1. So it's really 1 over this, 1 over this, 1 over this. Okay? That's really what it is. So if we see this kind of relationship, we don't have to do the power rule. We don't have to do, in fact, the U substitution won't even work for these guys. U substitution won't work because there's special cases. Okay? That's one way you'll know. You'll try U substitution and it won't work. One of the reasons is it could be natural log. One of the reasons is it could be one of these guys. Okay? Okay, so let's look at number 1. Okay. So let's say you're doing this problem like you were doing last week. Let's say we were doing this problem like we did last week. First thing we do is we change it, right? We change the power. Oops. 1 minus x squared to the negative 1/2 power dx, right? And then we would try U substitution, right? You would probably choose this guy here for U. But it wouldn't work. Why wouldn't it work? If we chose that guy for U, which is really the only thing we could choose for U, because 2 is just 2. It's not 2x. Why would this not work for U substitution? Why would this fail? Or, yeah, why would it not work for U substitution? Mm-hmm. Yeah, because if I found the derivative of the blue, what would the derivative of the blue be? 2x, negative 2x, right? Divide by negative 2x, I get 1 over negative 2x, right? And then I were to plug it back in. Would anything cancel out with that x? No, there's nothing in there. If there was an x, if it was 2x in front, if this guy was 2x in front, then yeah, it would cancel out. But it wouldn't if I did U substitution. That's kind of one way to tell, okay, there's got to be another way. There is another way. That way is using one of these guys. Okay? So the problem that we're dealing with right now, which one does it match the best? When I say match, I'm talking about this side, the left side of the equal sign. Which, don't worry about the du on top, that just means 1. Right? So in other words, I can move the 2 to the front. Okay. So now which one of those guys, the 3, does it match the best? Well, let's see. It has a square root. So it's not going to match this guy. This guy doesn't have a square root. Okay. This guy has something squared minus something squared. This guy has the same thing, but it has something out here. It has a value. This value here is also out here. We don't have that for ours. We don't have this guy for ours. But we do have this value. What is it? What would be A and what would be U in our case for our problem? 1 would be A. Not x squared. What would be U? X, just X. X would be U. Okay. So let's rewrite this. So let me rewrite this. 1 to 1 over 2. 1 x. Okay. So now 1 over the square root of 1 squared minus x squared. So now this is going to be the antiderivative. So we don't have to do u substitution. U substitution wouldn't work. We don't have to do anything else. This is the relationship. So it's going to be arc sine or inverse sine. Inverse sine and arc sine are the same thing. Okay. So we have 2 times, because the 2's still out in front, arc sine or inverse sine, remember. You can use this notation as well. Let's see, 1 over A, secant. Okay. You can use those notations as well. They're the same notations. Inverse. Inverse just means here is the ratio, what's the angle? On normal trig questions, they say here's the angle, they say here's the angle, what's the ratio, right? That's how you guys usually use your table, right? You go to your table, you usually have the angle, right? And then you go, okay, so the angle, and then you go over and look here, right? These are all the ratios. Arc or inverse reverses that and says, okay, I'll give you the answer. Where is that answer located? Okay, so it's just reversing. That's all inverse is. It just reverses the process. It gives you the answer. Where is that the answer for? What angle is that the answer for? That's all this is. Okay? Okay, so arc sine or inverse sine. U over A. U over A. So we said A was 1, and we said U was X. So it's going to be X over 1. Now we're not going to use a plus C here because we have bounds. I have bounds. So we actually have to evaluate these. Okay, so we're going to plug in. So the antiderivative is this. This is the antiderivative. What I have to do is now evaluate it. Plug in 1, get an answer. Plug in 1/2, get an answer. Okay, so 2 times arc sine of 1 minus 2 times arc sine of 1/2. So arc sine of 1/2. When they say arc sine or when they say inverse sine, that means here's the answer. The answer is 1. Where is it an answer for? Where is 1 an answer for sine? So you go to your sheets and look for sine when sine is 1. When is sine 1? Think at pi over 2. That's it, right? Yeah, that's it. Pi over 2, right? Now, when is sine 1/2? When is sine 1/2? Pi over 4? Pi over 6. Pi over 6. And then 5 pi over 6, right? So let's use pi over 6. Usually we just do the first one. So this would make 2 pi over 2, which is the same thing as pi. This would make 2 pi over 6, which is the same thing as pi over 3. We need a common denominator. So common denominator is going to be 3. And we get 2 pi over 3. 3 pi's minus 1 pi, because this is 1 pi, is 2 pi's over 3. You know? Okay. All right. Okay, so let's look at another one. Let's look at letter B now. Okay. So letter B. You could rewrite this again. On a test or a quiz, if you were to see this, you would probably, first thing you would do is rewrite it to get rid of the fraction, right? You don't have to write this because it won't work, but I'm going to show you. On a test or a quiz, this is probably what you guys would do because it's what we're used to, right? But right now, you should be able to see that U substitution won't work for this guy. It will not work for the same reason it didn't work on the last one, because this would have to be my U, right? And the derivative of that's 2x. If I put in x back in, there'll be too many x's. So there's got to be another option, and there is. It's arc tangent, or arc secant, or arc sine. Okay. Well, the only one without roots is arctangent. The only one without roots is arctangent. So that's the one we're going to use for this one. So root 3, negative 1, 1 over 1 plus, so it's going to be 1 squared and x squared dx. Okay. So 1 over a. Well, in our case, a is 1, so it'd be 1 over 1. Arctangent. U over a. Well, u is x, a is 1, so it'd be x over 1. Plus c. But again, we don't need a plus c since we have bounds. And we're going to evaluate it from the square root of 3 to negative 1. Okay. Okay, so arc tangent of square root of 3 over 1, which is really just the square root of 3, minus arctangent for negative 1. So we go to our sheets and we say, where is tangent the square root of 3? Where is the ratio for tangent square root of 3? What's the first place it is? Pi over 2. So that's the one we're going to use. Like I said, if there's multiple ones, just use the first one. Pi over 3? Pi over 3. Minus. And then where is tangent? Negative 1. What is it? Pi over 3 pi? Over 4. Okay. We're going to need a common denominator. So between 3 and 4, I think the common denominator is going to be 12. So we're going to have to multiply 1 by 4 and one of them by 3. So the common denominator is going to be 12. So you get 4 pi minus 9 pi, which is negative 5 pi. Okay. So again, the hardest thing about these guys, is recognizing when to use them. When I'm doing these problems, the way I recognize them is, does U substitution work? If U substitution doesn't work, right? These are 3 things I would put on my note card when you guys take your test. These are 3 things I would put on my note card. They're not often shown. They're not going to appear a lot, but they might appear once, and you want to get that answer right. You want to definitely get this answer right. So, like I said, there will be some times when U substitution doesn't work. More than likely, this is the guy. Especially if there's a square root on the bottom. You'll be able to tell. Okay? Okay, so I want you to try letter C. Try letter C. So this one has the same relationship as, wrong way, as the one we just did. The only difference is you can move the 5 to the front and make it a 1. So we're going to use arctangent. A is 1. Or sorry, A is X. U is 1. Okay? But you could flip it around. Could I switch U and A here? Yeah. It would still be 1 over X, 1 plus X squared, right? They're interchangeable. It's not subtraction. Okay? So it's going to be the same thing we just did. The only difference is it has a 5 in front. So we're going to multiply our answers by 5 and plug in the new values. So 1 over A arctangent U over A, so X over 1, oops, forgot about the 5. And then from 1 to 0. So even if you switched up x and 1 and you left it the way it was, you would get 1 over x over 1 over 1, which is the same thing. So you would, it would be the same thing. Okay? So let's plug in 5 times arctangent of 1 minus 5 times arctangent of 0. So we go to our charts and we figure out where is tangent equal to 1. Pi over 2? No. Pi over 4? Pi over 4, so 5 times that. And then 5 times arctangent of 0 is at 0, right? So that goes away. You get 5 pi over 4. Okay, so letter D doesn't have any bounds. It does not have any bounds, so we're going to give that one a plus C. That one matches the last one we haven't done, arcsecant. You see that U's in front, so U is going to be X, A is going to be 4. Sorry, U is not going to be, sorry, it's going to be 2 squared because 4 is squared, so it'd be 2. Because the relationship says something squared minus something squared. X squared would just be x squared, but to build 4, you would need 2 squared. Okay? So U is going to be X, 2 is going to be A. So 1 over 2, arcsecant, X, absolute value of X over A. Is it over A? Yep. Plus C. No bounds. So we stop there. Okay. Okay, so the last thing, very last thing, is something called average value. Very easy to do since you've been doing it. You've kind of been doing it, but the concept is a little bit weird. Okay. So it's got 2 names. One is called the average value. A lot of times you'll see average value. Sometimes they'll say the mean value theorem of integrals. You guys did a mean value theorem last semester with derivatives. This is the mean value theorem of integrals. So when they say the mean value theorem of integrals, it's the same thing as this, average value. They have 2 names, okay? They just have 2 names. So here's the formula here. Average value, you have bounds. So what you do is you make a fraction in front. 1 over top bound minus bottom bound. Do your antiderivative, use substitution, whatever, evaluate. Once you get an answer, multiply it by the fraction in front. That's it. Okay? That's all it is. So it's exactly what you've been doing, just multiply by a fraction in front, whatever fraction is created by the bounds. Okay, it's the same thing you've been doing except just that little part. Okay, now here's the same thing here. Here's the same formula here. Okay, what is average value? You're trying to find the average area under the square. It's trying to tell you what the average area under the curve is. It's not really important. More so, what is it? How to find it. So that's what I focus on the most, like kind of what is it? I could go into what is it, but it's really not necessary. If you want to know what's into it, you can do your own research on it, but I really don't. Average value is just mainly the average value. Over the bounds, from the bound to the bound, from one bound to another, what was the average value? What was the average area? That's all it is. Okay? Mean value theorem is the same thing. If you remember from last semester, mean value theorem says what is the average rate of change from here to here? I started here, I finished here. What was my average rate of change? What was my slope, right? From here to here. It's the same thing, except instead of taking an average derivative, we're taking an average integral, antiderivative. Okay? Okay, so let's look at a problem. So all this kind of explains what it is, but essentially, this is how to do it. So let's go to number 2, example number 2. I think there are 3 problems. We'll try to do all 3, but essentially it's the same thing. You guys, it's nothing difficult. Okay? So let f be the function defined. So f of x is negative x squared minus 4x. What is the average value? So be careful. When they say average value, that means integration. If they say average rate of change, that's derivative. Because you just see, so a lot of times I have students see the word average and they automatically do derivative, especially when we start reviewing. Average value and average rate of change are completely different. They're actually opposites of each other. Okay? So average value is integration, which we're doing. We're going to use that formula we just saw. Okay? So here's the interval. Because average value and average rate of change problems look very similar. They give you an interval. The word average is in there. They give you a function, right? Average rate of change is what we did last semester, which I'm going to do with my Math 3 today. But average value is different, okay? Okay, so the formula. One over b minus a. So b is the top bound. So first thing, let's build this guy. So we got to figure out what b and a are, because they don't tell us. Okay? So let me write this down, so we don't have to keep going back and forth. 1 over b minus a, and then b a dx. Okay. So what number goes on top of the bound? The bigger number or the smaller number? The bigger. Always the bigger number goes top, right? So out of those bounds, which one's the bigger number? Positive 1, right? Positive 1. So let's build it. Right? It's from negative 1 to positive 1. So positive 1 is b, negative 1 is a. So it's going to be 1 over b minus a. And then the function is negative x squared minus 4x. Well, the fraction that's going to be in front is just 1 over 2. Minus a negative 1, 1 over 2. Now you're just finding antiderivative. How do I do the antiderivative here? How do I do the antiderivative here? What am I going to have to do? You get two options: power rule, U substitution. Power rule. Yeah, I don't need U substitution here. Find the antiderivative of this guy, find the antiderivative of this guy, and you're done. So it's going to be the antiderivative of negative x squared. I add a power. So if I add a power, I make it 3, right? Divide by that new power. So instead of dividing by 3, I'm going to multiply by 1/3. The negative 1 comes from the front. I just made this a negative 1 here. Okay, next guy, minus, add a power, divide by that new power. This guy I'll divide by 2 since 2 goes into 4 evenly. And I'm going to evaluate it from 1 to negative 1. Actually, you know what? I should have put these guys around here because the 1/2 is times it all. Okay, so let me clean it up. So we got 1/2 times negative 1/3 x to the third power minus 2 x squared. And I have to evaluate that from 1 to negative 1. Last step, plug in 1 for x, plug in negative 1 for x, subtract your answers just like we've been doing. See what you get. So I get 1/2 negative 1/3 x cubed minus 2 x squared. So I'm going to plug in a 1 and a negative 1. Just like we've been doing. Everything here we've been doing. The only difference was the fraction in front, where that came from, the balance. So let's see. This is going to be, let's see, so 1/2 negative 1/3 minus 2. And this is going to be positive 1/3 minus 2. Okay. So now I just got to do some here. Okay, so 1/2, let's see, 1/2 times, what is that going to be? Was that 6/3? So negative 7/3. And then 1/2 times negative 5/3. Distribute. So you get negative 2, 6, which makes negative 1/3. So the average value, This is not the area under the curve. This is the average value. Okay, that's different. Like it's not the derivative, it's the average rate of change. So they're different. So this is the average value. The average value from -1 to +1 is -1/3. Okay. Okay, so let's do same problem. The only difference is this one's trig. Still gonna do it the same way. We have 1 minus b, 1 over b minus a, b a f of x dx. So I know the function is this, pi over 3 times x. The bounds, the top bound is the bigger bound. 9 over 2 is the bigger bound, so that's going to go on top. 1/2 is going to go on the bottom. So the bigger bound goes here, the smaller bound goes there. So the better you can do mental math, the easier this is going to be. So if I subtract 9/2 minus 1/2, I get 8/2. What is 8/2? 4. So it's 1/4. Okay. And then I have 9 over 2, 1/2, and then I have sine of pi over 3 times x dx. How am I going to do the antiderivative here? Again, you have two choices. Power rule like we just did, or U substitution. We only have two options here. We only got two rules we can use. So how am I going to find the antiderivative for this guy? Can I use the power rule? No. How do I know I can't use the power rule? Because this is not x. If this was x, just find the antiderivative of this. But this is not x. So you have two options for U substitution. I can use the whole thing, or I can just use the inside. Which one is it going to be? When you're trying to decide, think of the derivative. Whose derivative is also in here? What's sine's derivative? Do you see a cosine anywhere? No. So I would not use that. I would not use sine. What's the other option? Pi over 3 times x. What's the derivative of pi over 3 times x? Isn't pi over 3 just a value, right? So it doesn't need to cancel out with anything. Bingo, there you go. That's how you decide. Okay. Pi over 3x du is pi over 3 du. Divide by pi over 3. So you get du equals, I have a fraction under a fraction. Oh, sorry, dx, yeah. Yep. I have a fraction under a fraction. Well, instead of dividing by pi over 3, what's the rule? Multiply by the reciprocal. Flip it. 3 over pi. Okay. Now I'm ready to plug everything back in. So I got a 1/4 in front. the bounds. I'm not worried about the bounds yet. I'll deal with those later. U is the angle. And I got to plug in 3 over pi. Well, 3 over pi is just a value. It's a constant, so I can move that in the front. I'm not going to let that. That's not going to make any problems. So what is the antiderivative of sine? Cosine. Okay. Put u back in. I get 3 over 4 pi times cosine of u, which was pi over 3x. Uh-huh. Okay, so negative. Put negative in front. 1 over 2. Last step, plug in 9 over 2 everywhere you see an x. Plug in 1/2 everywhere you see an x. Reduce it. Evaluate it. And you're done. So let's see. Let's plug in 9 over 2. So negative 3 over 4 pi times cosine pi over 3 times 9 over 2. That's the first guy. Minus negative 3 over 4 pi times cosine pi over 3 times 1/2. Okay. I can reduce this guy. This guy can be divided by 3, so can this guy. So now I have to figure out. So this guy is 3 pi over 2. So I got to figure out what is cosine of 3 pi over 2. So what is cosine of 3 pi over 2? 0. We like zeros because zeros cancels things out. The other guy is cosine of pi over 6, 1 pi over 6. So what is cosine of pi over 6? Square root 3 over 2. Well, 0 times anything is 0. So this whole side is just going to go away. So we don't have to worry about it. So let's see. We'll get negative 3 times 3, square root of 3. And on bottom, we're going to get 8 pi. But I had a negative in front as well. So those negatives will cancel each other out. Done. As far as you can go. Leave it as pi because you can't use a calculator. So just leave it as pi. And you were done. Okay. There's one more problem on here, but essentially it's the same thing. It's the average value. They give you f of x. The only difference here is a log problem. It's just a log. But you guys have done logs before. It's the same thing. It's not anything different than you guys have done. Okay. I'll do this problem in the notes that I'll post. So if you want to see it, I'll do it, but I'm not going to do it